Hello student, in last class we talked about path of contact. In this lecture we will see about length of arc of contact and the second topic which is contact ratio. So let's start length of arc of contact. What is arc of contact? The arc of contact is the path traced by a point on the pitch circle from the beginning to the end of engagement of a given pair of teeth. So exactly the another diagram is very complicated, which I will show you after this. So that's why I have taken this diagram. In this diagram, as you can see, this is the one teeth and this is a point which is exactly the starting point of engagement, and this is the B point. So this AB is path of contact. Yesterday we derived the path of contact, and so now in this diagram you have to only see what is arc of contact. Okay, so if you see, as from the definition says that point on the pitch circle. So where is the pitch circle? This is the pitch circle. So on this pitch circle, AP is one arc and PB is another arc. Okay, so AP, like yesterday we have path of approach, this AP is called arc of approach and this PB is called arc of recess. So exactly we have yesterday another diagram where we had this pressure line, this pressure angle and all, but that diagram is somewhat not clear, so I referred this diagram. Now I will come to the main diagram, which is this. Exactly, yesterday I explained my hand drawn diagram, but the diagram was this, and exactly I have taken this from Kurmi and Gupta. Okay, so you can follow that Kurmi and Gupta for this topic. You can also see the another textbook, SS Ratan. Okay, only the notation will change. So now the length of arc of contact here, it will be GP. This is the G point on the pitch circle and this is the P. So GP will be the arc of approach and P, and here it is F point. So the PF will be the PH, sorry. So PH will be the, because it is not visible, that's why I followed this diagram. Here you can clearly see what is the arc of approach and arc of recess, but the thing is here the notation is different. Okay, so here the second arc is PH, the first one is GP. So GH is your arc of contact. Like the path of contact, here also we have two parts, arc of approach and arc of recess. Okay, so let's see how we will calculate the length of arc of approach. So if you come here, the length of arc of approach GP is length of path of approach by cos phi. Okay, so arc of approach will be length of path of approach divided by cos phi, so Kp by cos phi. In the same way, length of arc of recess will be the length of path of recess divided by cos phi, so PL by cos phi. Kp and PL we already know, yesterday we derived. Okay, so total length of arc of contact will be summation of arc GP, which is arc of approach, and arc PH, which is arc of recess. So total length of arc of contact will be equal to KL by cos phi, like Kp plus PL. Summation, we will get KL, and exactly KL was our length of path of contact. So if you divide length of path of contact divided by cos phi, you will get the length of arc of contact. Okay, so this is the next concept after path of contact. And the second topic which I want to explain in this lecture is contact ratio, or which is also called, will also give the number of pairs of teeth in contact. Okay, so we will see what is contact ratio, and obviously I am following the Kurmi and Gupta PDF. So the contact ratio, or the number of pair of teeth in contact, is defined as the ratio of length of arc of contact to the circular pitch. Okay, so contact ratio, or the number of pairs of teeth in contact, is length of arc of contact divided by PC, which is circular pitch. If you remember, in terminology we considered PC is equal to circular pitch, which is pi d by t, pi d by t, and d by t is module. Okay, so PC is equal to pi m. You can also say pi m. Okay, so this is not exactly important. We know that yesterday you derived path of contact KL. Okay, then from path of contact we can get length of arc of contact by dividing by cos phi, where phi is the pressure angle. Okay, so we saw this here. Length of arc of contact is equal to length of path of contact divided by cos phi, and from length of path of arc of contact we can get contact ratio by this formula, which is contact ratio is equal to length of the arc of contact divided by circular pitch. So from path of contact we can get arc of contact, and from arc of contact we can get contact ratio. Okay, so that was not that much important, but here the thing which need required to explain is here. For example, the contact ratio cannot be less than 1. What is the meaning of this? If, for example, if the contact ratio is less than 1, means the number of pair of teeth in contact is less than 1, which means for a fraction of time the teeth is not in contact. This means the contact ratio will be always greater than or equal to 1. Minimum 1, but it will be always greater than 1. So what does it mean? For example, if the contact ratio is usually not a whole number, so for example if it is 1.6, it does not mean that there are 1.6 pair of teeth in contact. Okay, then what does it mean? It refers that for 60% of time there will be 2 pair of teeth in contact, and remaining in 40% of time there will be only 1 pair of teeth in contact. Okay, so that is the meaning of contact ratio 1.6. So what here it is written, it means that there are alternately 1 pair and 2 pairs of teeth in contact on a time basis, and the average comes is 1.6. So as I explained here, for 60% time there will be 2 pair of teeth in contact, and remaining, if you take the engagement period as total time period. Okay, so for 60% time period of engagement there will be 2 pair of teeth in contact, and for remaining 40% time only 1 pair will be in contact. Okay, so again here it continues contact ratio. It is additional note you can follow here. QT is assuming for contact ratio and P for circular pitch. So QT by P is equal means it is contact ratio is 1. This means that the one tooth and its space will occupy the entire arc AB. Exactly he is talking about in terms of this notation. Okay, so you can understand. I already explained the meaning of what is the here it is talking about exactly 1.2 contact ratio. Okay, so the thing we should understand is what is the meaning of 1.6 contact ratio. Okay, so it generally mean, it's just example, it can be different also. Okay, so I explained here what is contact ratio and what is arc of length of arc of contact. Okay, so first, path of contact, length of path of contact. From length of path of contact we can get length of arc of contact, and from length of arc of contact we can get contact ratio. Okay, so with this lecture completes, and after this I will explain one theoretical problem.